I'm going to demonstrate a Kruskal Wallis test from the SSO3 paper, and this particular example is from June 13. Kruskal Wallis test is easily recognisable because it's the only test that we have statistically to test for 3 categories at SSO3 level. What we've done here to start this question is about 3 different psychological approaches that are given to treat patients who've experienced a traumatic event. H0 is that the samples are taken from identical populations. H1 is that samples are not from identical populations. We're testing at the 5% significance level as given in the question. The first thing to do in order to look at this test is to rank the levels of stress from 1 to 16 or 16 to 1. The different colour font here is due to the fact that for one of the solutions given in the exam solution sheet, they've done it from the smallest to the biggest and one from the biggest to the smallest. At the end of the day, it won't affect the overall statistic that you get for Kruskal Wallis. So, using the black rankings here, which started with the highest post-traumatic stress level as number 1, the values are given from 1 to 16, and then the ranks are totaled for column 1, column 2 and column 3. The Kruskal Wallis formula is a really heavy formula, but it's given in the formula book, and I think the exam solution does what I would suggest actually doing, and that's working it out part by part. So the first thing that you're going to do is you're going to work out each of the totals squared divided by how many you've got, how many items of data you've got in that particular category. So for example, the first ranks came to 75, and that was for a group with 6 items of data. So 75 squared over 6 plus 33 squared over 5 items of data, and 28 squared over 5 gives a total for the sigma ti squared over ni of 1312. That's then multiplied by 12, which is a fixed number, 16, which is actually, I think they call that n, which is the total number of items of data, multiplied by n plus 1 in the formula. And then on the end, we take away 3 lots of n plus 1. And that gives a Kruskal Wallis statistic of 6.89. It's well worth practicing finding that Kruskal Wallis statistic. It's a very well repeated method that's used every single time and is available in all of the textbooks. The Kruskal Wallis test statistic is then compared with the chi-squared table, and this value of 5.991 is the 5% significance level with 2 degrees of freedom. The 2 degrees of freedom come from the fact that we've got 3 groups and we take 1 away from that to get our degrees of freedom. In this particular case, as we're looking for upper tail significance, so with the chi-squared test I would advocate actually drawing a diagram. The chi-squared is slightly positively skewed. We've got 5.991 is our critical value and a test statistic of 6.89. So you can see that the test statistic lies in the critical value and leads us to reject H0. So we reject H0 and say that we have significant evidence to suggest that the samples are not from identical population, i.e. at least 2 of those differ. So what is quite often then asked at the end of the question is for us to look and to see exactly where perhaps that difference is arising. And it seems to be, or in this case we're asked to recommend a treatment, it seems to be that approach 1, since average of the ranks is highest, that would be the method that we would give in order for the highest positive result for post-traumatic stress. So that's the one that would be the preferred option. They quite often in this particular question will lead to a rejection of H0 in order that they can facilitate you answering a part B.